So traditional app designs often focus on two-dimensional interfaces. And we are talking about layout, color, typography, and of course, the user interaction within a flat screen. Now, with the spatial design, the users are actually interacting with a three-dimensional space, which actually needs an extra way of thinking about how the users see objects in the real world and how we could eventually interact with them. Let's begin our exploration by analyzing the fundamental elements that define the structure of a VisionOS app. So, hi everyone. Okay, I can just remove this thing, that's enough. And I can switch back to real HD graphic. But before that, just let me put my glasses. Yeah, that's not that comfortable. Oh yeah, now I can look, I can see you. All right, so I'm PIETRO MESSINE. I'm a senior iOS dev. I started actually building apps in 2012. Then I built around 20 apps my own, so I'm also an indie dev. I exited some of them. I built already 3 apps on Vision Pro, and that's why I have it. I flew all the way to New York to buy it on day one. I met some people that actually I think are not here today, but yeah, it doesn't matter. And if you're following me on Twitter, you may have already seen my $1 million App Ideas community, in which I'm basically helping indie developers to build or increase their app portfolio. So in this session, we are going to explore how we can basically leverage Swift and VisionOS. As it's a kind of new technology, I want to be the pioneer of this, and that's why I decided to give, or at least to switch my talk today, because my original talk was another one, and then I decided just to move it and speak about the Vision Pro. So let's go through the agenda, quickly through the agenda of today. We will be talking about the shift towards blending digital and physical worlds. Then we will explore the VisionOS capabilities in spatial computing. We will see how Swift empowers us developers to create some futuristic apps. We will dive into core principle of designing for spatial computing. Then we will see the insight into the extended reality design and some user experience challenges that I encountered while building those apps. Some key concepts for developing with VisionOS, and then we will just be closing our Q&A. So let's begin our journey from where we actually started. So today we stand at the threshold of a new era, an era where the digital and physical realms converge to create experiences that are beyond our wildest imagination. I don't know if you actually have had the experience of testing Vision Pro, but it's a complete new revolutionary device. And so this is called the area of spatial computing. Today, we are not going to see only the technological advancement of this device, and I'm talking about the Vision Pro together with the VisionOS, but we're going through a journey that should inspire you to create some futuristic apps for this device. Apps which actually are gonna blend with and integrate with the digital interaction together with the physical world. And so, thanks to the powerful combination of Swift and VisionOS, we have all the tools for build such apps. And so, in this image, you can actually see not a concept, but a real application made in collaboration between Porsche and Apple, in which they can actually, and you will be able to do that as well, see in real time the performances, BPM, so heart rates of the driver of the Porsche and the current circuit over there, and in which position he is in the circuit at the right time. So as developers, designers, and innovators, we are actually the architect of this new area. And together, we are going to explore how we can leverage Swift and VisionOS to open up new opportunities for creating some futuristic applications. So these are actually not only applications that we are used to imagine, because until now, we are used to build applications which are two-dimensional. But today we are gonna, not today, but since now on, actually since February when Apple released the Vision Pro, we are gonna build some new apps which are basically blending digital content together with the physical world around us. And so I invite you today to embark this journey with me, and we will see how is the role of VisionOS. So VisionOS is conceptualized as a cutting-edge operative system that powers the spatial computing devices. That's how Apple basically specified this device, a spatial computer. So it's basically referring to a technologies, once again, that allows a digital object to interact with physical environment in 3 dimensions. And it powers, or at least it's having several features, for example, virtual reality, augmented reality, and mixed reality. But so what's the purpose of such a device? And what's the purpose actually of VisionOS? So it's to serve as a foundation for these interactions. And so basically it should enable devices to understand and circumnavigate into our physical space in a way that should enhance the user experience. And so the aim is to make the digital content not only visible, but also interactive, so you can actually interact with them in the real world. So VisionOS facilitates the spatial computing by integrating a wide array of sensors, cameras, input methods. And all of these things, as you can see over there, it's field of sensors and cameras that actually user cannot see. Maybe, I know it's a bit far, but there is like this black panel, so you cannot really see it from like far away, but even they are visible only the cameras. You cannot see other sensors. And thanks to all of these things, allow VisionOS to place, for example, some digital objects into the real world. And thanks to the input methods, because thanks to, for example, the LiDAR scanner and the downward cameras, is also able to understand our gestures in order to interact with the objects that are placed over there. And that's not it, actually, because we can also have amazing full immersion experiences, which are called virtual reality things in other platform or devices. So which are the features and capabilities of VisionOS? Let's start with the key features. So thanks to the 3D spatial awareness, basically the device is able to recognize and map the physical space around the user. So it's able to understand what's around us, and based on that is also able to allow us to interact with the digital content in the real world. Then we do have also high fidelity graphics, audio and video. So thanks to the possibility of the CPU, which is basically empowering this device, we can offer great visual experiences, as well as, of course, thanks to the spatial audio, amazing high-quality audio experiences. But that's not actually it. We can use also, it's also integrating some advanced input methods which are allowing the user to interact naturally, like he's interacting with a real or physical object, but actually with a digital object. Let's quickly see what I'm talking about. Yeah, that's how the average user is like interacting with like digital objects in the real world. So, but let's come back to the reality. We do also have the developer tools. So basically, us developer can build, thanks to the APIs, all kind of applications. And so it's only up to us what we can build, which we can build like games or even some entertainment or educational type of apps or tools or even productivity tools. So let's see some real world applications which have already been made and some that have been like announced. For example, education. There can be the possibility to create such an interactive and interesting learning experience for students, where you can actually explore, for example, historical sites or even some 3D models of anatomy, things like hearts and stuff like that. Then we can also move to healthcare. Imagine how surgeons could help or assist other medical equip in order to do some operations, or even just analyzing XR and all of those things. Or how about the retail? If you remember, one of the big companies like IKEA, which used to build in 2017 back then the app for place furnitures inside your home, and with Vision Pro is much way more comfortable and looks like even better because you can actually see it through your eyes directly into the space of your flat. And how about remote work? Well, I think that remote work is one of the most interesting applications because you can basically see all the people around you, and it doesn't actually matter if they use Vision Pro or they are connecting from browser or whatever. Because, for example, right now Google Meet is not available on Vision Pro, so you need to connect through browser. But still, they see you as 3D persona because, you know, cameras are not like just pointing at you. And 3D persona actually sucks right now. And how about gaming and entertainment? Well, there are still companies which are building some games for Vision Pro, but, you know, we will make it also to there. Imagine also Pokemon Go working on the Vision Pro. That would be super cool. Let's see some like the Swift and VisionOS and Spatial Computing. So developers can actually use Swift in conjunction with ARKit in order to build amazing features. Because if you had experience with Vision, how many of you had experience with ARKit actually? Oh, wow. Not many people, actually. OK, interesting. So for who does not have any experience with ARKit, you can actually place 3D objects through into the real world. And you can actually use ARKit in order to understand like your hand pose and so many other things. But that's not actually it, because you can also create some virtual reality experiences, even if it's not very much promoted by Apple, and it's not the main purpose of the Vision Pro, but still it's something that it can be actually possible to do. And how about mixed realities? Well, again, combining Swift and ARKit, developers can build amazing mixed reality experiences. For example, imagine some repair or some maintenance apps. You can just have your Vision Pro pointed towards, I don't know, the engine of a car, and you can see an instruction on what to fix, how to fix it. And about the extended reality is actually something which is pretty interesting and that hasn't been that much promoted in the past. But it's basically a mix of augmented reality and mixed reality together. So let's see the Swift Unix advantages in the special app development. So the integration with the ARKit, as we said, it plays a fundamental role. Because, as I was anticipating before, it has been released in 2017, and I guess they were just throwing the foundation for the Vision Pro apps, because basically it offers features for example, face tracking, image detection, and word tracking. And how about the performances? As Swift, as all we know, it's focusing on performances. It basically helps developers to build amazing applications which performs very good. And that's not only the thing, because the Vision Pro is powered by an M2 chip. And also the extensive ecosystem around Swift, and I'm talking about the documentation, the developers' tools, the community, are actually helping developers to build application real quick. And for example, about community, like vibrant community, there is an amazing community or website which is called the Swiftcraft, and which is basically giving you a lot of nice resources from where you can learn how to code. Let's move on now to the principle of spatial design. So unlike mobile apps, VisionOS immerses users in a spatial computing environment where interaction transcends touch screen, because you don't have anymore a physical device where you can actually touch. You have a 3D objects, and you are actually immersed in this new environment. And so one of the key principles is the presence. What does actually means? That we need to create, when we are building apps, a sense of being physically present in the digital environment. And so these actually involve leveraging several key factors. For example, the spatial audio, realistic visuals, and interactive elements that respond to the user actions in real time. And I'm talking about, for example, one of the apps that Apple made about the dinosaur is that you can look at the dinosaur and the dinosaur is actually looking at you and where you are moving around the room and is actually also interacting with you. So that's one of the key features that you need to consider when building such a kind of apps. And how about the interaction? So designing natural and intuitive ways for users to interact with the digital world. So I'm talking about the gestures. You should include as many natural gestures as you can if you want to build a nice experience, as well as, for example, voice commands, which could play also a good role. And we will see at the WWDC what Apple is going to implement in the new update of Siri with possibly some AI. And the scale and space also play a fundamental role because we should avoid we should consider also the position of the user into the real world and where you want to place objects in front of the user, like how far, how big, because it should be as natural and as real possible. Imagine to present the model of a pencil. You don't want to see a pencil that is 2 meters width and 5 meters height. I mean, it's not going to look real, right? And how about the user comfort? Well, we should avoid as much as we can to discomfort the user. So we should offer a more static, let's say, environment possible. We don't want to have windows moving around because otherwise the user can feel like some motion sickness. So how these principles differ from traditional app designs? So we are going to see now how does it look like a traditional app against the new vision or the new spatial designs. So traditional app designs often focus on two-dimensional interfaces. And we are talking about layout, color, typography, and of course, the user interaction within a flat screen. Because till today, users are basically interacting with a device which is a physical device that you can actually touch. But later on, we will see now with the spatial design, the users are actually interacting with a 3D space, with a three-dimensional space, which actually needs an extra way of thinking about how the users see objects in the real world and how he could eventually interact with them. And so that's why I put here the physical space interaction, because it's important to know how the user may interact with those objects in the real world. So let's begin our exploration by analyzing the fundamental elements that define the structure of a VisionOS app. So in VisionOS, we do have windows, volumes, tab bars, sidebars, ornaments, menus, and popovers, and sheets. So some of them, as you can see here, we find them as well on iPadOS and even iOS. So they should not be, and even in macOS, actually, the windows. So they should not be completely new to you, except for the ornaments, for example. But there are some variations. So let's start with windows. So windows are basically the foundational layer of each VisionOS applications. And they are actually a container for the digital content together with other elements of the interface. Usually there is like a window control, which is positioned at the bottom of the window, and it allows you to move it somewhere else in the real world. Then we have volumes. Differently from windows, basically volumes do not have frame and do not have even a background, the usual glass default background. And it allows you, the volumes differently from the windows are usually used for three-dimensional objects. So you can move around this globe, for example, to see it from all the sides. Let's move to the tab bars. So differently from iOS, in VisionOS, the navigation appears on the left side of the window and not on the bottom part. And for the optimal user experience, the maximum amount of tabs that you want to show, or items, is 6. And so when people look at the tab bar, it's automatically expanding. And if you want to open a specific tab, you can just focus the element and tap on it. When a tab in the tab bar is selected, actually, we do have a new component which can live along the tab bar. And I'm talking about the sidebars. which is something completely different from what happened on iOS or iPadOS, because you cannot have a sidebar and a tab bar at the same time. This is the Apple Music application, as you can see. And selecting the library icon that is highlighted on the left, it's actually bringing you up to a sidebar, which is filled with all the information related to the navigation. Then we can move to ornaments. Ornaments is one of the new features, actually, or at least new component that has been introduced on VisionOS. And it's a floating panel, which is a little bit moved up to the Z-axis. And it's always following the main window. So it's always keep its position constant on the window. And it can actually contain as many elements as we want, and it's fully customizable. So in this case, it makes sense for the Apple Music app to have all the player controls and all of those things. So it's very important item because you can actually offer the flexibility to craft some custom component in it. So it doesn't have to be like this, but it can be anything else. And how about menus? Well, actually, menus are very similar to macOS menus or iPadOS. Actually, they can open, and they have two styles. There is the small and large layout style. So when similarly to macOS, when you open a menu, it can actually also go outside the window boundaries, as you can see in this picture. And last but not least, the sheets. No, not these sheets, sheets. So we are used to know sheets like cards appearing from the bottom to the top of our iOS applications. But actually, in VisionOS, the sheets are a little bit different. And they are slightly reminding me the sheets on iPad. So they actually float in front of the parent window. And it's dimming the main window on the background for show the, let's say, prominency of it in the front. Let's move to another topic, the app icons. So app icons in VisionOS appears as circular app icons. So they are not anymore the usual square that we are used to see on iOS and iPadOS, but they are round. And they are composed by 3 layers, the background layer, the middle layer, and the top layer. Once you offer to Xcode these 3 images, it will automatically create some shadows. Let's see how does the Safari icon looks like. So this is the final result of all the things assembled together, and this is like the 3D example. So as you can see, there are shadows on the bottom, and everything is made from Xcode itself, so you don't have to struggle or make some fancy 3D icons. Just offer a background, the middle layer, and the top layer. So now I want to give you a quick overview on how it's easy to create actually some of the components that we saw before. So let's start with the essential ingredients for create some of those components. So we will see how to create windows and volumes, and also we will briefly see how we can ensure legibility and create some engaging user interfaces. So let's start with implementing Windows, but before that we need to understand how does it look a window, I mean in terms of default components. So by default, a VisionOS window has a modifiable background, which is called glass. It's a glass effect. This material basically offers some specular reflection and shadows, so you can better understand that it's a 3D-ish window. And so it basically blends with the content that you have in the real world behind this window. The usual measure, the default measure is 1280 by 720, and is positioned at approximately 2 meters far from the user. So that's an example of 2 windows which actually overlap each other. And so today I'm going to explain you how you can do such a thing, so how you can open a window. So first of all, you have to create 2 Swift UI views. So I'm not going to show you how to create Swift UI views because I believe you are junior enough to do such a thing. So for ease of use, we are going to call primary view and secondary view. So I will show you how you need to structure your app protocol to support multiple windows. So here, if you have experience with macOS, you will immediately understand that in order to open another window, you have to specify the ID. Specifying the IDs later on, it will allow us to call this secondary view from another code pushing a button, for example. So by default, as we did not specify any ID, we will open the primary view. And then from the primary view, we can place a button, and we will actually invoke the secondary view. So as you can see, we use the environment value open window, as well as dismiss window in case we want to dismiss it. And we just created a button which has the action open window with a specified ID parameter. And that's it, actually. You will be able to open a window like this. The picture here is of one of the apps that I built for the Vision Pro, which is actually a YouTube player, because YouTube decided to not release any official app. So I was like, okay, what am I going to do if I want to watch a video? I'm not going to do it through the browser because it's impossible to seek the seek bar. So I built a native YouTube player. So let's move to the volumes. So as I said before, volumes present 3D contents and allow users to view it from any perspective. And so volume serves as a containers for the immersive experiences. And so it allows us developers to place 3D objects in the real world. So it looks like this. So once again, in these experiments, it's going to be very similar to the code that we saw before. So the primary view is basically the same. And it looks like this. You have, again, like open window, dismiss window. And we are going to use the same approach for open a window. But the second one, so the secondary view, is the one that is going to look different. Why? Because it's the one related to the 3D volumes. And this looks like a very simplified version of the code that allows you to open a 3D model. In this case, you specify model 3D and the name of the scene in order to present the 3D object. Now I will actually show you the structure of the app protocol in order to support multiple windows, and these multiple windows should be the window that should present a 3D object without the glass view. So if you notice, the only difference is the modifier window style volumetric. Adding this modifier basically will allow you to have a window without frames and without background, so you will not have the glass background over there. And so you can present the object like this, the object like you see before in a three-dimensional space. Let's move on now to interface design. And let's see all the necessary components such as materials, typography, vibrancy effects, colors, and that's it. Let's go a little bit to do a deep dive into those materials. So the default materials, as we said, is the glass material. And as you can see here, is the default material for Windows. So if you see in this picture, you can see behind the window some furnitures and some stuff like that. And thanks to this 3D effect, you can see actually different colors that are being taken from the glass material itself. So one of the things which Apple is not recommending you to do, and actually is like very much forbidden, is to create opaque windows. Because look at the difference. It's awful, right? And you don't want to do such a thing in your apps. Another thing is the typography. So to increase legibility, you should, or at least it's recommended, to use bigger fonts, very big, and also Apple created a specific font, which is called extra large title 1, which is the one over there, which is used for titles. Because the windows are usually 2 meters far from the user, you don't want to use small fonts that may cause some issues in legibility. And now about the vibrancy. Vibrancy can be used for buttons or for text, for example. So right now we're going to see vibrancy for buttons. And one of the recommendations that I give you is to use native components whenever it's possible. Why? Because native components basically offer all of these vibrancy effects by default, so you don't have to reinvent the wheel. And now I will show you, just pay attention to the slide, the difference between like vibrancy effect turned on and turned off. And how does it look for text, actually? You can have primary type of vibrancy and secondary type of vibrancy. So once again, use native text or instead of like some custom fonts and stuff like that, because it can be easier to manage or improve legibility. And how about colors? Well, it's easy for you to understand which one of the two designs looks nicer and, let's say, more and easy to read. So whenever it's possible, use colors in the background layer or in the entire button. But, and not only that, use also the native Apple colors, because actually they are calibrated for increased legibility and they adapt dynamically to the UI and the contrast on the glass itself. So they should look better than your specified hex or RGB colors. Let's move to the second part of the interface design, the layout. So when you're preparing a layout, we have to take in consideration three important things. The screen size, which could be default 1280 by 720, or we can specify a custom design, a custom size of the window. Then buttons, so the dimension and the spacing of the buttons plays a fundamental role. Very soon we will see what is the recommended or the minimum dimension of buttons, and the spacing, of course, and the focus feedback. Well, as it used to happen on Apple TV, also on VisionOS and Vision Pro, actually, the focus is one of the key roles of this device. Because if you do not make a component which reacts with the focus in an easy way, the user will be misled and confused about where he's actually looking at, which buttons, which item, so he will not understand where he is looking at. So let's see the screen size. So generally, people prefer to move the head left and right, so rather than up and down. So because of this, if you have an app which is having so many components and they don't fit into the window, just make it wider instead of higher. Then about buttons, so we need bigger buttons, because once again, the windows are usually placed far away from the user. So the best approach is to make buttons at least 44 pixels. With a padding of 8 pixels. So at the end, it's going to be a square of 60 pixels per 60 pixels. Why? Because basically the target area is easy to focus with your eyes. And once again, you should also keep a space in between buttons, which should be at least of 16 pixels. So otherwise, the user will not be able to understand which items is focusing. But we will reach the focus very soon. So, and how about the small buttons like this one that we saw before in the Apple Music application? So in this case, the buttons basically allow us to collapse the playlist, and is having a dimension of 28 pixels. So it looks small, right? And it's actually broke the rule that we just said before. That's what you are thinking probably. But it's not like that, because basically the target area is of 60 pixels. So even though it looks like the button is small, the target area all the way around is 60 pixels. So it's easy to focus and select. Actually, Apple offers two styles of buttons, which is large and extra large. So one is 52 pixels and the other one is 64 pixels. And it allows you to avoid like any efforts of specifying sizes. Just use the one that Apple offers you. So what we learned today is basically that we always have to give 60 points of space for a button. And about the focus effect, so it's very important in giving confidence to people on what they are actually looking at and where. So it is very important to leave some space in between items. As I said before, 16 pixels of space, it should be the minimum that you should give. Otherwise, we will end up in the case in which it will not be very much understandable what they are looking at. Let's have a look at the animation of the focus. So this animation basically should simulate the eyes of the user when he's moving the eyes from one button to another button. Let's see the minimum padding of focus in a list, for example. This is the list of settings on Vision Pro. On the left, you can see the list without padding, which will basically not allow the user to understand where he's focusing at. And on the right, the correct one, which is basically a minimum vertical padding of 4 pixels. And now, last but not least, the focus effect for and the rule of round corners. So I guess that you should just take a screenshot of this or a picture of this, because it's very important also on your iOS applications. So the rule of outer corners is basically that you should have the inner corner radius plus the padding. So having this, it will basically have a perfect outer radius corner, which will look great. So we are reaching actually the conclusion of our exploration into the spatial computing with VisionOS and Swift. And it's clear that we are basically standing at the beginning of a new revolution. And the advancement that we actually discussed today are not like a distant future, and is not actually a sci-fi. As you can see, we have a Vision Pro, which I define it a sellable prototype, in the meaning that it's an amazing product which we can actually work on, but it's not ready yet to be a product that you can or that you would like to use every day. So, as I said, the future is basically now, and so I hope that I spark a bit of inspiration for your creation of some futuristic apps. So thank you very much for listening today, and if you want to follow me on Twitter, there is QR, and if you want to join the community, feel free.